In this video, we're going to do some more examples, this time with some more chain rule with powers and parentheses. So I'm just going to make up a whole bunch of problems and we're going to try them. So for my first one, I have g of x equals the square root of, how about x squared plus 7? That looks like a nice one. Okay, so I want to find the derivative of this. So the first step we want to do before I even take a derivative is to write this as a power. Okay, now once I have it as a power, I have my inside and my outside. So let's go ahead and go for my derivative. So I'm going to take the derivative of the outside. So I'm going to bring that 1/2 down. The new exponent is -1/2. Leave the inside alone. And then I'm going to multiply it by the derivative of the inside. And the derivative of x squared, 2x. Okay. Now, all we're going to do is clean this up. And so the first thing I want to do is I'm going to take this 2x and this 1/2 to the front. The 1/2 and the 2 will cancel, and I'll just get an x. Okay. Beautiful. Now, if you wrote this on the test, I would take it. If you go to check your work, though, it's not going to match the back of the book. And the reason why is because they originally gave the problem in roots, so they're going to want their answer in roots. Think of it like if we were talking to somebody in another language, we would want to talk in that language. So this language is roots. So what's going to happen is that this parentheses with a -1/2 is going to turn into a root, but because it's a negative root, it goes in the denominator. So there we go. That's 2 ways to write the same answer. Pretty fast, right? Okay, the reason why it was pretty fast is because I rewrote it with parentheses and a power, and I used my chain rule very patiently, saying my little mantra: derive the outside, leave the inside alone, times derive the inside. So let's go ahead and try another example. In this example, I have just a very small fraction, and some of you might be thinking, well, can I use the quotient rule? Of course you can use the quotient rule. You could totally do low d high minus high d low, square the bottom, and away we go. But what I'm going to show you is how you can actually do this problem using chain rule. So the first step is I'm going to rewrite that denominator as 3x plus 1 parentheses to the -1. So the 5 doesn't have an exponent on it because it's in the top. This piece has become moving upstairs, so I've got to the -1. Okay, so I've got an inside and I've got an outside, and this 5 is just a coefficient that's chilling. So here we go. I'm going to do the derivative. So I take the derivative of the outside, which is the power. So if I had x to the -1, if I was going to take this derivative, the -1 would come down, x to the -2. So that's what we're going to have. This 5 is going to hang out, -1 to the -2. Okay. I'm going to leave the inside alone. Don't touch it. But the second part of chain rule is once I take the derivative of the outside, now I take the derivative of the inside. So the derivative of the inside will be 3. All right, again, I'm going to join forces with this 3, the 5, and the -1 to make a -15. 3x plus 1 to the -2. And if you think about it, if you did this problem using quotient rule, you'd have a fraction. So let's rewrite it as a fraction. This to the -2 is my denominator. This does not have a negative exponent, so it's staying upstairs. So this would be -15, 3x plus 1 quantity squared in the denominator. And there we have it. 2 nice examples using parentheses and powers.